Thank you for joining today's webinar. This is Rowana Mbarak, and I'm the head of Potek Labs and Potek Academy. Our topic today is blockchain. If you have any question during this presentation, just send them via chat. We will have a Q&A session at the end to answer your questions. We will be sending you after the webinar a link to the presentation recording. So now we can begin. I would kindly ask you to mute your microphones, please. Let's get started. This presentation outline. The first section will define blockchain, provide a brief history of how this technology came about, and give an overview of the many sectors where blockchain technology can be employed. We will then look at the technology itself, how it functions, some key terminology, and the process of Bitcoin mining. Next, we will cover blockchain properties and advantages. Having assessed the strengths of the technology, we will pass to assess its main vulnerabilities. We will then explore the present and future of blockchain. At the end, we will turn to POCs. Blockchain technology has been long associated with cryptocurrencies, but its potential applicability stretch wide to a variety of this presentation aims to explain the technology behind blockchain, its potential uses, but also some of its vulnerabilities. How is blockchain technology used today, and what are its future ramifications? So what is the blockchain technology? Blockchain, sometimes referred to as distributed ledger technology, DLT, makes the history of any digital asset unalterable and transparent through the use of decentralization and cryptographic hashing. Blockchain technology is most simply defined as a decentralized distributed ledger that records the provenance of a digital asset. A simple analogy for understanding blockchain technology is a Google Doc. When we create a document and share it with a group of people, the document is distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to the document at the same time. No one is locked out awaiting changes from another party. While all modifications to the document are being recorded in real time, making changes completely transparent. Of course, blockchain is more complicated than a Google Doc, but the analogy is apt because it illustrates three critical ideas of the technology. One, digital assets are distributed instead of copied or transferred. Two, the asset is decentralized, allowing full real-time access. Three, a transparent ledger of changes integrity of the document, which create trust in the asset. Blockchain is especially promising and revolutionary technology because it helps reduce risk, stamps out fraud, and bring transparency in a scalable way. Although blockchain is a new technology, it already boasts a rich and interesting history. The following is a brief timeline of some of the most important and notable events in the development of blockchain. In 2008, Satoshi Nakamoto, a pseudonym for a person or a group, published Bitcoin, a peer-to-peer electronic cash system. Satoshi Nakamoto he refers to it as a new electronic cash system that is fully peer-to-peer with no central and trusted third-party authority. In 2009, the first successful Bitcoin transaction occurs between a computer scientist and the mysterious Satoshi Nakamoto. In 2010, the first ever purchase using Bitcoin was used to buy a pizza. In 2011, one Bitcoin equal to $1, and the Electron Frontier Foundation, WikiLeaks, and other organizations started accepting Bitcoin as donations. In 2013, Bitcoin market cap surpassed $1 billion. Bitcoin reached $100 per Bitcoin for the first time. Also, Vitalik Buterin published Ethereum project paper suggesting that blockchain had other possibilities besides Bitcoin. The main characteristic in Ethereum is smart contracts. In 2016, the tech giant IBM announces a blockchain strategy for cloud-based business solution. Governments of Japan recognize the legitimacy of blockchain and cryptocurrency. In 2017, Dubai announces its government will be blockchain powered. In 2018, Facebook commit to starting a blockchain group and also hints to the possibility of creating its own cryptocurrency. Also, IBM develops a blockchain-based banking platform with large banks like Citi and Barclays signing on. Blockchain has already endless amount of application across almost every industry. The ledger technology can be applied to track fraud in finance, securely share patient between healthcare professionals, and even acts as a better way to track intellectual property in business and music rights for artists. How does it work? The second section will illustrate how blockchain technology works, some key terminology, and the Bitcoin mining process. The basic parts, we have the record. It can be any information, a deal, for example, the block, a bundle of records, and the chain, all the blocks linked together. So every chain consists of multiple blocks, and each block has three basic elements. In each block, we have the data in the block, a 32-bit whole number called a nonce. The nonce is randomly generated when a block is created, which then generates a block header hash. And we have the hash, which is a 256-bit number wedded to the nonce. It must start with a huge number of zeros, so it will be extremely small. When the first block of a chain is created, a nonce generates the cryptographic hash. The data in the block is considered signed and forever tied to the nonce and hash unless it's mined. You might heard also about the miner. So the miner creates new blocks on the chain through a process called mining. In a blockchain, every block has its own unique nonce and hash, but also references the hash of the previous block in the chain. So mining a block isn't easy, especially on large chain. Miners use special software to solve the incredible complex math problem of finding a nonce that generates an accepted hash. Because the nonce is only 32-bit and the hash is 256, there are roughly 4 billion possible nonce hash combinations that must be mined before the right one is found. When that happens, miners are said to have found the golden nonce, and their block is added to the chain. So here's how a deal gets included in a chain. Step 1, a trade is recorded. For example, let's say Mr. A is selling 2 of his coins to Mr. B for $100. The record lists the detail, included a digital signature from each party. Step 2, the record is checked by the network. The computer in the network, called nodes, check the details of the trade to make sure it is valid. Step 3, the records that the network accepted are added to a block. Each block contains a unique code called a hash. It also contains the hash of the previous block in the chain. So here we have a consensus that is achieved. Step 4, the block is added to the blockchain. The hash code connects the block together in a specific order. There are basically 3 types of blockchain. Public blockchain. In a public blockchain, a user can become a member of the blockchain network. This means they can store, send, and receive data after downloading the required software on their device, allowing anyone to read and write the data stored on the blockchain as it is accessible to everyone in the world. A public blockchain is completely decentralized. The permission to read and write data onto the blockchain are shared equally by all connected users, who come to a consensus before any data is stored on the database. So the most popular example of a public blockchain is Bitcoin. The digital currency allows users to use a platform for making transactions directly between them. Private blockchain. In a private blockchain, permission to write, send, and receive data is controlled by one organization. Private blockchains are typically used within an organization with only a few specific users allowed to access it and carry out transactions. The organization in control has the power to change the rule of a private blockchain and may also decline transactions based on their established rules and regulation. An example of this is a blockchain deployed by a corporation to collaborate with other divisions or a few permissioned participants. Consortium blockchain. A consortium blockchain, also called permissioned blockchain, can be considered as a hybrid model between the lower trust offered by public blockchain and the single highly trusted entity model of private blockchain. Instead of allowing any user to participate in the verification of the transaction process, or on the other side, just allowing one single company to have full control, in a consortium blockchain, a few selected parties are predetermined. It only allows a limited number of users to permission to participate in the consensus process. For example, imagine a group of a network of 10 banks, each of which is connected to the blockchain network. In this example, we could imagine that for a block to be valid, 7 of the 10 banks have to agree. Although there is some degree of centralization in this structure, users can get permission to read or write to other users. This leads to the partially decentralized design of consortium blockchain. Similar to private blockchain, the consortium blockchain keeps the privacy of the data without consolidating power organization. An example of this is Marco Polo, which is a banking initiative to trade finance. The proof of work. The proof of work is a consensus algorithm for preventing double spend. Double spending is when the same funds are spent more than once. Proof of work is a consensus algorithm used in the Bitcoin DLT. The proof of work was used also in Ethereum early releases. Then in the latest releases of Ethereum, they have moved to a proof of stake consensus. So proof of work typically relies on mining. Mining is the process of adding transaction record to the chain. So what is exactly blockchain mining? It is a peer-to-peer computer process. Blockchain mining is used to secure and verify Bitcoin transactions. Mining involves blockchain miners who add Bitcoin transaction data to Bitcoin Global Public Ledger or past transaction. In the ledger, blocks are secured and are connected to each other, forming a chain. When we talk in depth, as opposed to traditional financial services system, Bitcoins have no central clearinghouse. Bitcoin transactions are generally verified in decentralized clearing system wherein people contribute computing resources to verify the same. This process of verifying transaction is called mining. It's probably referred to as mining. It is analogous to mining of commodity like gold. Mining gold requires a lot of effort and resources, but then there is a limited supply of gold. Hence, the amount of gold which is mined every year remain roughly the same. So in the same manner, a lot of computing power is consumed in the process of mining Bitcoin. The number of Bitcoin that are generated from mining dwindle over time. In words of Satoshi Nakamoto, there's a limited supply of Bitcoin. Only 21 million Bitcoin will ever be created. At its core, the term blockchain mining is used to describe the process of adding transaction records to the Bitcoin blockchain. This process of adding blocks to the blockchain is how transactions are processed and how money moves around securely on Bitcoins. This process of blockchain mining is performed by a community of people around the world called blockchain miners. So anyone can apply to become a blockchain miner. These blockchain miners install and run a special blockchain mining software that enables their computer to communicate securely with one another. Once a computer installs the software, joins the network, and begins mining Bitcoin, it becomes what is called a node. Together, all these nodes communicate with one another and process transactions to add new blocks to the blockchain, which is commonly known as the Bitcoin network. User are so this mechanism formed the pivot around which the Bitcoin economy revolves. While the cost and difficulty of mining Bitcoin individually continues to increase, several cloud-based mining services have gradually emerged. These services allow individual users to lead the processing power of mining equipment and mine Bitcoin remotely. However, you can mine Bitcoin in person too. As for the process, so blocks are where the complex mathematical code is stored. User must then solve the mathematical problem using their computer CPUs and GPUs to run the problem-solving software. Once the problem is solved and a consensus is achieved, Bitcoin are transferred to the miner unique address. So now that we have illustrated the technology and the processes behind blockchain, we can turn to uncover its properties and main advantages. Blockchain greatest characteristic stems from the fact that its transaction ledger for public addresses is open to viewing. In financial system and businesses, this adds layer of accountability, holding each sector of the business responsible to act with integrity toward the company's growth, its community, and customers. Due to its decentralized nature, blockchain removes the need for middlemen in many processes for fields such as payment and real estate. In comparison to traditional financial services, blockchain facilitates faster transaction by allowing peer-to-peer cross-border transfer with a digital currency. Better security. So blockchain is far more secure than other record-keeping systems because each new transaction is encrypted and linked to the previous transaction. Blockchain, as the name suggests, is formed by a network of computers coming together to confirm a block. This block is then added to a ledger, which form a chain. Blockchain is formed by a complicated string of mathematical numbers and is possibly to be altered once formed. This immutable nature of blockchain makes it safe from falsified information and hacks. Its decentralized nature also gives it a unique quality of being trustless, meaning that parties do not need to trust to transact safely. Improved traceability. While the blockchain ledger, each time an exchange of goods is recorded on a blockchain, another trail is present to trace where the goods came from. This is done using a miracle root tree hash. This can not only help improve security and prevent fraud in exchange-related business, but it can also help verify the authenticity of the traded asset. In industries such medicine, it can be used to track supply chain from manufacturer to distributed in the art industry to provide an irrefutable proof of ownership. So distributed ledger allow a cryptographic audit trail that is secure and searchable. The smart contract is one of DLT's most promising applications because it makes the system programmable thanks to contractual logic. This means that any contract can be executed by an automated process. So a transaction is initiated by a user. The smart contract verifies that the transaction fits the condition. The platform creates the order and broadcasts it to the network. Then a consensus is reached. Finally, the ledger and the position are updated. So DLTs are programmable. So smart contract can be programmed to follow business logic, immutable. Any validated records are irreversible and cannot be changed. Secure, all records are individually encrypted. Distributed, all network participants have a full copy of the ledger for full transparency. Timestamp, transaction timestamps are recorded in a block. It is unanimous. All network participants agree to the validity of each of the records when reaching a consensus. So blockchain technology is theoretically hacker-proof. However, as we will see in the next section, the technology holds some important vulnerabilities. Addressing the shortcoming of the technology will be key in rendering it secure and applicable to various economic and public sector. Blockchain vulnerabilities, the storage. So blockchain ledger can grow very large over time. The Bitcoin blockchain requires 200 gigabytes of storage. Sometimes it is inefficient. Especially blockchain using proof of work are inefficient because the work of any miner is wasted. The private keys. Losing a private key will not allow a user to access his or her funds. The 51% attack, it's also known as the majority attack. So if one entity manager control more than 50% of the network hashing power, so it will be able to take control of the network. Data modification. Blockchain stability is not all advantages. Changing data and code is demanding and often requires hard work. So the main concept of blockchain is decentralization, and it has imperative allegation on the security. Blockchain mining malware and DOS attack are reported constantly. In this slide, we can see some of its vulnerabilities. 1. Anonymity. Metadata exposure disturbs the participant anonymity and reduces confidentiality. Besides, being aware of a user address will lead to the history and changes tracking for financial and non-financial application. Thus, the implementation of pseudo-anonymity identity mixer relying on cryptographic scheme in the Hyperledger network and the introduction of the whisper routing protocol in Ethereum blockchain to conceal sensitive interaction. However, a malevolent mixer can misbehave. Furthermore, in order to achieve better privacy, the concept of channels was presented. The idea is to segregate the activity and do not use the blockchain for every transaction. Off-chain functions that were originally conceived for scalability purposes have advantages on user secrecies as well. 2. The consensus. Several consensus algorithms have been employed in DLTs, depending on the altcoin time. For Bitcoin and Ethereum early releases, the proof of work algorithm suffered from multiple drawbacks. Regarding the Ethereum alteration to a proof of stake algorithm for a patent consensus in the new release, also new attack vector come upon this later. 3. Wallets. So the principal purpose of wallet is to keep private keys. Several types have been utilized, namely paper wallet, mobile wallet, desktop wallet, hardware wallet, and online wallet. Preserving private keys from loss or theft is crucial. However, these wallets are subject to failure or attack, and in some scenario, not irreversible. The introduction of multi-signature addresses and cloud storage system may enable damage resistance unless collusion. So to open a parenthesis here, so Enigma, one of Potex's entity, allows to trade cryptocurrency in the most secure way by tracking wallet transactions and flow of funds. So Enigma helps you make an informed decision on the level of risk you are willing to incur. So maybe later on we can schedule a webinar for that. So returning to the vulnerabilities, smart contract vulnerabilities. So numerous causes make smart contracts principally susceptible to errors. The first reason is related to the vulnerabilities in the high-level programming language supported, especially the Solidity language in Ethereum. Moreover, the fact that a transaction is irremovable or unchangeable, it will be challenging to remove the code security flaws once added to the network. The solution will consist in auditing smart contract code security primarily and adding expiration date to the DApp secondly. Furthermore, publishing newly discovered system weaknesses will let the hacker take advantages of these vulnerabilities and conduct unpredictable fraudulent activities. Besides, some DLT features are not permanently useful, especially when the blockchain network is under attack. Transaction security. So blockchain security depends on cryptographic scheme and is based on networks management over keys. The transaction authenticity is corroborated applying digital signature, and each transaction points to the previous one. Each transaction is broadcasted between the peers for validation, whereas this allows adversary to delay the message delivery and may help in conducting double spending. Also, another implication is denying the delivery of transaction. Moreover, a more recurrent example of exploitation consists in controlling the target user inbound and outbound connection by implementing an Eclipse attack. Time-jacking attacks. So an attacker could typically change node's network time counter by involving as multiple peers as possible and broadcasting wrong timestamp in the network. This results in speeding up other peers and isolating the target out of the network without interference from authentic nodes. The tightening of time range and the usage of peer system timing or blockchain median time might be a possible solution. Lightweight client. The security included in the lightweight client is lower than in the standard nodes. These nodes are light and simplified version of node that contain only chunk of the blockchain in mobile application, for example. 8. Cryptography contravention. Elliptical curve digital signature and SEC 256 that are applied in DLT are considered strong cryptographic schemes. However, they must be cracked by private key harvester in the far future. Thus, an attentive and innovative approach needs to be considered in future releases architecture. Besides, latest attack against weak elliptical curve digital signature in cryptocurrencies have been presented. 9. Snapshot attachment. A snapshot consists in compiling unspent transactions in order to bootstrap a new blockchain. So attaching a snapshot to the network may have a huge security implication, specifically when reusing the same address in outgoing transaction. Targeted DDoS attack. These attacks target the most critical actors and consist in flooding the network by lots of information in a way it becomes irresponsible to transaction. Some of the known attacks are highlighted here. For the Bitcoin, Ripple, Ethereum, Hyperledger, Algorithm, and IOTA DLT. IOTA is a new type of blockchain which was developed for IoT application. So where is blockchain technology currently employed? What can we envision the future of this technology to hold? These are the questions we seek to answer in this last section. The blockchain was as part of the cryptocurrency Bitcoin. However, the practical application of blockchain extend far beyond cryptocurrencies, and the technology is likely to impact many industries. Let's look at some real-world example of blockchain technology in action. So companies like Uber, Airbnb, and Expedia act as aggregator, like a centralized platform that connects provider of a service with customer who need that service. The centralized aggregator is the one in control here. They set their own terms and conditions and naturally take a cut of each transaction as their fee. So blockchain are now being used to cut out the middleman and create a secure, decentralized way for service provider and customer to connect and transact safely and directly. The world's largest tourism company, TUI, is pioneering to use of blockchain as a way to eventually replace travel aggregator like Expedia. The company already uses a private blockchain to house its contract, but is keen to create a public blockchain where agents and customers can engage directly with hotels. But TUI isn't always in their endeavor. Winding Tree it is another company working to create a decentralized travel booking system. So expect to hear a lot more about blockchain disrupting the travel industry over the next few years. Improving the healthcare. Blockchain provider Simply Vital Health has already created two blockchain products that are designed to improve healthcare management. The first, Connecting Care, track the progress of patients after they leave hospital, and the second, Health Nexus, is designed to provide decentralized blockchain patient records. Better banking and transaction. Barclays has already launched a number of blockchain initiatives for tracking financial transactions and combating fraud, and Bank Hopolim is collaborating with Microsoft to create a blockchain for managing bank guarantees. Smarter supply chain. Knowing the status, condition, and provenance of every product on your supply chain is key for businesses. And for consumer, provenance is becoming an increasingly improvement issue. Efficiency in the world of insurance. Nationwide insurance company is trialing a blockchain solution called RiskBlock, which provides proof of insurance information. The goal is to help law enforcement and insurers, not to mention the insured, to verify insurance coverage in real time. Clearly, blockchain is still in its infancy and has a long way to go before it can be considered even close to mainstream. Yet these examples show how industries are beginning to wake up to its advantages. And as the technology matures, we can expect to see even more companies investing in blockchain. So let's look at the main blockchain development trends that are expected to be. Last year, we saw an increase in funding for blockchain startups. However, like any new technology, blockchain is still immature in its implementation. So it can unmeet the expectation of investor. As a result, many blockchain startups are expected to be just a waste of time and money. False starts in blockchain development will lead organizations to failed innovations. And technology in the future will affect every aspect of businesses, but this is a gradual process that requires time. Gartner predicts that most traditional businesses will keep an eye on blockchain technology, but won't plan any action, waiting for more examples of the best application of blockchain technology. Economy and finance will lead blockchain application. Unlike other traditional businesses, the banking and finance industries don't need to introduce radical transformation to their processes for adopting blockchain technology. After it was successfully applied for the cryptocurrency, financial institutions began seriously considering blockchain adoption for traditional banking operation. National cryptocurrency will appear. Russian President Vladimir Putin was the first who proposed to issue crypto as a national cryptocurrency. Obviously, governments have to recognize the benefit of blockchain-derived currencies. At the rise of Bitcoin, governments expressed their skepticism regarding the particular application of cryptocurrency. However, they had to worry when Bitcoin became a tradable currency that couldn't be controlled by any government. Earlier this year, Venezuela has already launched its national cryptocurrency Petromenada by the country's oil and mineral reserves. So the government of Venezuela hopes that this cryptocurrency will allow bypassing the US sanction and attracting international finances to the country. By 2022, Gartner predicts that at least 5 countries will issue a national cryptocurrency. Blockchain integration into government's agency. So the idea of the distributed ledger is also very attractive to government authority that have to administrate very large quantity of data. Currently, each agency has its separate database, so they have to constantly require information about residents from each other. However, the implementation of blockchain technologies for effective data management will improve the functioning of such strategy. Blockchain expert will be in high demand. So despite the blockchain is on the top of its popularity, the job market experiences a lack of blockchain experts. 6. Blockchain means the Internet of Things. IDC reports that many IoT companies are considering the implementation of blockchain technology in their solution. Therefore, IDC experts expect that nearly 20% of IoT deployment will enable blockchain services. The reason for this is that blockchain technology can provide a secure and scalable framework for communication between IoT devices. Besides, blockchain will allow smart devices to make automated microtransactions. Due to its distributed nature, blockchain will conduct transactions faster and cheaper. To enable transferring money or data, IoT devices will leverage smart contracts, which will be considered as the agreement between the two parties. Low integration into smart contracts. Besides the cryptocurrency, blockchain technology benefits us with another convenient possibility such as smart contracts. So the main idea of smart contract is its automatic execution when conditions are met. For instance, delivering goods after payment is received. However, other conditions of contracts should also be automatically regulated. So now that we have looked at the blockchain technology, the properties and advantages, the vulnerabilities, some application, blockchain present and future, we will turn to proof of concepts. In this POC, we will create a web application that verifies the existence of computer files via timestamp transaction in the Bitcoin blockchain. So one of the applicability of blockchain is the chance to immutably record and document into the known public distributed ledger. So proof of existence has been here for a while and has become a pretty handy tool when it comes to public proof and authenticity of any record or document, because even today, an email or a signed message sometimes might not be enough to prove something. So we will be using Node.js, Teron, RethinkDB, PubNub, and JS3 code. So in a few words, without entering into details, these applications allow you to store the hash of a file in Bitcoin blockchain so that anyone can certify that the file existed at a specific time. This has many advantages. First, it demonstrates data ownership without revealing actual data. It checks for document integrity. 3, using the blockchain, you can certify the existence of the document without the need of a central authority. 4, in practice, this decentralized proof cannot be erased or modified by anyone. 5, it is anonymous, so others cannot identify you or your data. So using our application, we will be able to upload a file by dragging and dropping it to a marked area. Then its hash digest will be calculated and sent to the blockchain using a hash API. The hash of the file and the blockchain received given by Tyron is stored in a RethinkDB, a NoSQL database with real-time capability. And when Sharon alerts us that a block of hashes has been processed, we update the verification page and the list of verified documents. So as you can see, once the hash is anchored to the blockchain, we can check it using sites like Block Explorer or blockchain.info and get the receipt. So you can also verify that the file has been certified in the blockchain. To sum up here, how do I verify the existence in the blockchain? Well, first of all, the file SHA-256 hash digest is unique. So you need to have the exact same file to generate the same hash. Just trying checking the hash of a file and then adding a space to see how the new hash is completely different. This proves that the file existed at least as early at the time of the transaction was confirmed. So otherwise, the hash we used would not have been generated. With a Miracle tree, you can prove that something belongs to a set without having to store the whole set. So to validate a receipt, you must confirm that the target hash is part of the Miracle tree and the tree's Miracle root has been published to a Bitcoin transaction. The second POC is two-factor authentication using blockchain. So every organization has hundreds of applications and databases, and its employees access them every day using their credential, the username and the password. An attacker with such valid credential can bypass existing security solution as they look like a legitimate user. Two-factor authentication is an extra layer of security that is used to ensure that only the legitimate owner can access their account. So in this method, the user will first enter a combination of a username and password, and instead of directly getting into their account, the user will be required to provide other information. This other piece of information can come in one of the following forms, either something that the user knows, a PIN, for example, something that the user has, a token, something that the user is, biometric data. So how can blockchain transform two-factor authentication? So by leveraging blockchain, we can ensure that this sensitive information never remains on the database. Instead, it can be within blockchain nodes that have immutability and can't be modified or deleted. So the following diagram shows a blockchain-based two-factor authentication. In this system, user devices will be authenticated by a third-party two-factor authenticator provider through the blockchain network. Each party in the blockchain network will hold the endpoint's information securely and will activate the two-factor authentication system to generate the second-level password. So for this POC, we will be using the Ethereum blockchain to turn up the two-factor authentication system. Ethereum allows an application to be programmed with a smart contract. In the following diagram, the basic flow between the user, the web application, and Ganache, which is an Ethereum-based repository, is depicted. So a user accesses the web portal and enters the first level of credential. A web application will communicate to the Ethereum-based repository to generate the OTP and share it with the user. Finally, the user enters the same OTP and gains access to the web application. So the three main components include a blockchain network, a smart contract, and a server communicated with the blockchain. So we start by developing a decentralized application, DApp, on a local Ethereum called Test RPC. So in our case, we are using the Ganache, and it uses Ethereum to simulate full client behavior and make Ethereum development easier and safer. So after creating the environment, we'll get 10 default account and 10 default private key. So each account will have a balance of 100 Ether. And then we will run out our server. For testing and verification, we need to run the smart contract code in the Ethereum IDE, which is accessible with remix.ethereum.org. And as you can see here, we have the Solidity code, two-factor authentication.sol. And for verifying the authentication, so in this step, we need to verify whether the authentication works. So to accomplish this, first we need to set the environment field to the Web3 provider option. and we choose the two-factor authenticated option and provide the contract address. So as you can see, the Web3 server is set with the address of Ganache. So it is the same address of the RPC server. After deployment, we see that the balance of the address is now 99. So it was 100 Ether. So this amount was used to create the transaction. After deployment of the two-factor authentication.sol, we can see now the different function method, and we can call the authenticate method. So after deployment, we have three methods: the authenticate, the server, and the URL method. And as you can see, the status of the transaction, it is successful, true, transaction mined, and execution succeeded. So the server reads that from the blockchain and returns with a successful authentication. So to conclude, in just over 10 years, blockchain technology has made enormous advances. Its properties yield some important advantages that can render it applicable in numerous economic and social sectors. Blockchain distributed nature renders it theoretically immune to cyber threat, but we have seen that there are serious security concerns surrounding this technology. The future will undoubtedly see the adoption of blockchain technology in numerous sectors where efficiency and data protection is paramount. The references of this presentation can be found here. And that's all for today. Now we have some time to answer your questions. Any question? Okay, I have one question. What about Lebanon's situation concerning blockchain? In fact, we have many initiatives and applications, but they are still immature yet in Lebanon. As I said before, at Potec, we have two solutions. We have Enigma, which provide us the possibility to check the level of a particular cryptocurrency wallet. So we can question if a wallet is secure, yes or no. Enigma solution will allow us to trade the cryptocurrency more securely by tracking the wallet transaction and the flow of funds. Also, we have another type of application which can be integrated into any SAM solution. We have log on blocks, which allow us, like the proof of existing POC, to check if any type of log has been modified, yes or no. We have also other initiatives here in Lebanon, but nothing related to cryptocurrency is official yet. I don't know if we have any other question. I don't think so that the banking system will, it can be solution for our banking system and regarding the flash money and capital haircut. So it's not related because our funds are locked in the bank. So I don't think that cryptocurrency will be a solution for us.
It can be, hi everybody, Joanna, it can be maybe a way to pressure the banking system to be more flexible in case there's another way to bypass the transactions and the fresh money coming from outside using cryptocurrencies. It can be a way of pressure.
Yes, maybe. Okay, I'm checking the messages. I don't know if I missed any question. Okay, is there anything else you want to mention? Any other question? Yes, I have Muhammad here that the most problem, the transaction is not saved in the database. Truly, true, Muhammad.
Joanna, there's a question regarding the difference between blockchain and IOTA as well.
I didn't see it. Hello?
Joanna, hey, Joanna, there's a question regarding difference between blockchain and IOTA. I don't know if you answered.
Yeah, okay. I was a bit disconnected. Regarding blockchain IOTA, so IOTA, I think was developed in 2017. IOTA DLT rely on a different type of blockchain. So it uses the DAG technology. So it's not like the real blockchain when we have a consensus and other things like that. It uses a DAG, so we have a snapshot attachment. So every transaction from every transaction will have like 2 points that initiate from it. So this will make the transactions and when dealing with the transaction really fast. So this is will be helpful in many financial institutions. So it was developed for financial purposes between several banks. So several banks holds actually its development, and it will be really helpful for us for IoT application because it is really, really fast. If you want, I can share with you a comparative between the blockchain and IOTA DLT. I have done a study on that. I will send you by email, maybe. But it's still in the development phases. So we have actually many research topic on this related to how to use IOTA in IoT application. Yes, sure. I'll be sending you the comparison. Okay, I can see that Mr. Stefan is typing a question. Can we buy Bitcoin in Lebanon? No, not for now. We don't have what you say here. agent for selling Bitcoin. So we need to connect to an agent and we buy through the agent Bitcoin. Here in Lebanon, we don't have yet this possibility.
But we can buy from any exchange using fresh external credit cards. John, if you want to use your external credit card.
But not directly. Exactly. We don't even have US to buy it. Okay, I don't have. Have I missed any other question? Okay, so it looks like I covered everything. Thank you for your time. Thank you for your participating in today's webinar, and we hope to see you again next time.